Today we're going to look at combinations, very similar to permutations, and that problem number 24 from yesterday's homework essentially set up the difference between the two. And when I answered it, I said, by allowing items to be reused in a permutation, that's what makes it a combination. So, a combination is an arrangement of items in a set with no particular order. So order is not important in a combination, which means stuff can be reused. There's also a formula with combinations. Looks like this. The way that is it's n items. Combination of n items chosen r at a time, taken r at a time. Once again, just like with permutations, n stands for the total number of items, and r is the number taken or chosen. I have a question for you. Is this formula the same as permutation that we did yesterday? Yeah, there's something extra in there, isn't it? Let me now, this you do not have to write down. I'm just putting it up there for you to compare and see exactly what's the difference between those two. Right, there's an extra r right here. What does that mean? That means times r factorial. So you're going to have an extra factorial number down there. Well, no, not double it. It'll be different. Hey, if this number is 8, you're not doubling it, are you? No, it's 8 times 7 times 6, 5. Yeah, it'll be the same number. So how does that work, I guess, is what you're asking, correct? All right. Well, let's see. How does it work? We're going to do a combination of 4 choose 2. Or 4 taken 2 at a time is how it should be phrased. Well, just applying the strict formula, it would be 4 factorial over 4 minus 2 factorial times 2 factorial. Now realize I chose these numbers on purpose because they're small and it will be easy to calculate. On the bottom, what's 4 minus 2? 2 factorial, right? What is 2 factorial? 2, right. 2 times 1 is 2. 2 factorial is one of the easier ones. This is 2 factorial times 2 factorial, and we know 2 factorial is just the number 2. So 2 times 2, and I'm left with simply 4 on the bottom. What do I have up top? 4 times 3 times 2 times 1. Right. So the 4's cancel. I'm left with 3 times 2 times 1, which is 6. So the combination of 4 choose 2 is 6. A permutation of 4 choose 2 would be 12. Because you don't have this extra 2 outside. That's what accounts for things being able to be reused. Is that extra r factorial on the outside on the bottom. Okay, how about this one? Combination of 6 items taken 4 at a time. Can we use the shortcut we had yesterday? Yes, we can, to cut out a little bit, to cut out this step right here, right? But what else do we have to do? We still have to make sure we put that r factorial down. So I'm going to go ahead and still use that shortcut with permutation, because the combination formula is the permutation one plus a little extra, right? So I can still apply what we did with the permutation. I do 6 minus 4. What's 6 minus 4? 2. So all numbers bigger than 2 will get multiplied on the top, right? Because 2 times 1 cancels. So that'd be 6 times 5 times 4 times 3 times 2. Oops. Times 3. Stop there. Because it's all numbers bigger than 2. And that canceled with the 6 minus 4 on the bottom. But what do because this is a combination, what do I still have to have on the bottom? Yeah, the extra one, which would be 4 factorial. This number, factorial. So 4 factorial on the bottom, which would then become 4 times 3 times 2 times 1. what you will find with combinations, there's a lot more canceling that you can do because they're extra number. Go back to the formula. It's the n minus r, which would cancel on the top, right? But you have the extra r factorial times this. With, right, what was 6 minus 4? 2, right? So the 2 and the 1 here cancel with the original 2 and the 1 from inside the parentheses. You follow me? I can write it out if. Okay, so I still have that other 4 factorial here. Okay, so now I'm going to cancel 4 and 4, 3 and 3. What else? Am I done? Can I cancel that way? 2 goes into 6 3 times. 3 times 5 is 15. So that's 15. Now realize I could have started off, when I started to cancel, I could have said this. 3 times 2 is 6 and just canceled with the 6 right away. I could have done that too. Why didn't I use that? I could have. Now wait a second. 6 times 5 is 30, right? And I would not have canceled the 2. What's 30 divided by 2? So what did I do? I divided by 2 first. I canceled the 2 and the 6. And 6 divided by 2 is 3. All right. Good question. All right. So far so good? Now you're probably sitting there thinking to yourself, or maybe you're not, and I'm going to put this thought in your head, hey, I can just do this in my calculator, right? Yeah. Until you get something like that. Not going to be able to. Go ahead and try. Go ahead, try. Do this one in your calculator. I'll pause the recording. In order to do this one on the calculator, you need to be able to do this. 20 factorial on your calculator divided by, then you need to have the brackets to do, and inside that the parentheses, 20 minus 9 factorial times 9 factorial. And then close the brackets. And guess what? These calculators aren't advanced enough. Oh. So you got to do it like I did it before we even had anywhere near these kind of calculators. But the good news is, my first and second period classes, they said it's easier to do it my way anyway. So you ready to learn my way? Since you don't have much choice anyway. We're going to use some of the permutation canceling, and then we're going to do a whole lot of canceling. We know the top number is 20 factorial, right? And that's 20 all the way down to 1. The first part of the bottom is 20 minus 9, correct? Yes or no? What's 20 minus 9? So what's going to cancel on the top and the bottom? 11 down, correct? So I'm left with, on the top, all numbers bigger than 11, right? Now, it doesn't matter if you write 12 times 13 to 14, 15, or backwards, 20 down to 12. Multiplication is commutative. You can do it either way. Whatever way is easier for you to think of it. What do you have left with on the bottom still? 9 factorial, right? Not just 9, 9 factorial. So on the bottom you have this. If you want to write that down, and then we'll go. Let me know when you're ready. Okay, here comes your canceling. You ready to cancel? Okay, let's see. 9 times 2 is 18. 5 times 4 is 20. Right? Do you see how I'm just combining the numbers on the bottom to get some numbers on the top? What else can I do? Let's see. Well, it's times. It's times. Well, I don't have any others I can combine, but I can start doing them individually now. 7 goes into 14, and then I have 2 left over. Let's see, 6 goes into 12, and I got 2 left over. 8 goes into 16, and I have 2 left over. 3 goes into 15. And I have 5 left over. So what happened to all those numbers on the bottom? They just canceled. I'm left with 1, right? So on the top I now have 2 times 13 times 2 times 5 times 2 times 17 times 19. Which I can do on my calculator now. You should get like 176,000 something. 960, I think. No, should be 176,960. You missed something. 176,960. So we are going to combine a little bit of the canceling with permutation to get rid of the stuff on the bottom that would be in the 167. Oh, I transposed numbers. Thank you. 167,960. Thanks. 167,960. So like I said, we're going to use that permutation canceling, but you cannot forget to have that second number factorial on the bottom after you cancel out inside the parentheses with the top. Okay, how about that one? 5 factorial. You know that, right? Okay. We'll see. Okay, I'm going to give Marcus 5 different pieces of candy. What that question is asking is how many combinations of 5 things, and you're going to take all 5, can you have? Okay, Marcus, take all 5 pieces of candy. How many ways can he do it? 1. Go ahead, you can keep them. Why does this work this way? In combinations, when these two numbers are the same, it's 1. Why is that? Because you have 5 factorial over 5 minus 5 factorial, which on a permutation would be 0, but you have this extra 5 factorial out there. This ends up being 0 factorial, 5 minus 5, so that is 1. 1 times 5 factorial is just 5 factorial, so I have 5 factorial over 5 factorial, which is 120 over 120. Any number divided by itself is 1. So with combinations, when they're the same, it's 1 because of that extra r factorial at the end. All right? I bet you don't forget because you got 5 pieces of candy out of the deal. All right. That's a cheap teaching tool. Okay, everybody get ready to do this one when I say go. Ready? Go ahead, figure that one out. All right, you should be done. Good. You are on a roll. You're the only one who's caught it so far. You should have been done. Why? How are you going to take? How can you take 5 things and then take 6 at a time, given 5 things? You can't. It's impossible. What's the answer to this? Empty set. Empty set. Cannot be done. So the number on the left has to be bigger than the number on the right. Good. Okay, how about this one? That can't be done. Good. Why not? You can't take negative 2 items, right? You can't have 5 things taken negative 2 at a time. This one also, empty set. How about this one? Can't do it. Very good, because it's not a whole number. Right, Tyler? So what kind of numbers do these have to be? Whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. Right. All those numbers have to be whole numbers. 0, 1. And not only do they have to be whole numbers, but the number on the left has to be bigger. That has to be bigger. Otherwise, it's impossible. Yeah, that's to remind myself to make sure I say it. Most people don't notice that, but you're close enough you can see it. How many different ways can a two-person committee be chosen from 8 people if there are no restrictions? Now, what makes this one a combination, not a permutation? This phrase right here, if there are no restrictions. That's what makes it a combination, not a permutation. So I see that there are no restrictions, and I translate it immediately to combination of 8 taken 2 at a time. All right, we need to simplify that. After I cancel, 8 minus 2 is? So what numbers will I be left with on the top? 7 and 8, good. All those numbers bigger than 6. What will I have on the bottom? 2. What's the second number? So what's the factorial of? 2 factorial, which is just 2. 8 divided by 2? 4. 7 times 4 is 28. Okay? You sure? Okay, good. This is your second, and this is the other one after the other stuff cancels. It's this number right here, that number factorial. In this case, 2 factorial was just 2, so I didn't have to write out the factorial. A random drawing is held to determine which 2 of the 6 members of the math club will be sent to the regional math contest. I'm sure they have a bunch of pocket protector vendors there too. The math club. Go ahead, make fun of the math club. I was not in the math club, so they're much bigger dorks than those of us in the band. How many different pairs of 2 can be sent to the contest? How many people do I have? How many are you going to choose? 2. Combination of 6, choose 2. So, 6 minus 2 is? What numbers will be left on the top? 5 times 6. What number goes on the bottom? 5 times 3 is 15. You have 15 different ways to send those people. If the members of the club are James, Dante, Colin, Daphne, Nashota, and Nicole, what is the probability that James and Nashota will be picked? No, you're adding. Do we add? Right. How many times does James appear? How many times does Nashota appear? What am I going to do with those 2 numbers? Multiply. 1 times 1 is? What were the total? 15. Right? Because there's 15 different ways, but there's only one way to pick those 2 people. 1 out of 15 probability that they are chosen. A card is drawn at random from a standard deck and is set aside. A second card is drawn. What is the probability of drawing 2 aces? No, it is not. Okay, now this could be done how? Dependent probability. Very good. And that is the way I would probably do this problem. They're asking for this. What'd you get? No. Probability of ace, then ace. You missed something somewhere. What's the probability of choosing an ace the first time? Yes. What am I going to do? What operation? Multiply. What is this one going to be? Very good. You multiply those together, and you get 1 and 221. That's the easiest way to do this problem. There is overlap. Just like the permutation stuff, some of this stuff can be simplified as just a dependent probability problem, which I think is a lot easier. Let me show you how to do this as a combination problem. Oh, yeah, maybe I'm confusing this with another problem. One and 221. Okay. I don't know what. Yes, it would. Okay, thank you. 12 out of, what was that number? 22, 2652. Yeah, there are 4 aces. Then when you choose one, it should be 3 out of 51. Who said that? Bonus points for you. What is this reduced to? 1 and 221. So you can get there, of course, as long as you don't screw up like I did. Because there are 4 aces, then 3 aces after you choose the one, right? Dependent probability. If you're choosing the same thing, they both go down, both the top and bottom number. Right. How do I do this as a combination problem? It's much worse. I don't know why you would do it that way, but you could. To pick the ace for the top, it would be a combination of 4 choose 2. Right? There are 4 aces in a deck. What would be the bottom? A combination of 52 cards, right? How many am I going to choose? 2. Combination of 4 choose 2. That was what? 6. Yes. Now the combination of 52 choose 2. So this would be a fraction on the bottom. To get the bottom, we would cancel. 52 minus 2 is 50, correct? So what numbers am I left on the top? 52 and 51. Over just the 2 factorial, correct? This number, I still have that, which is just 2. So those cancel, and I'm left with 1 there and 26 there. 6 over, what's 26 times 51? 1326. And that reduces to 1 and 221. So which way is easier? Yeah, I like that way a lot better myself. All right. Pages 180 and 181, 1 to 21 all.